Good morning. Good morning. I'd like to talk about again the quantum mechanical new hypothesis. Well, it seems to be that it's not a new hypothesis. The hypothesis that I'm postulating has, in maybe another way, already existed for since de Broglie, and that's the Broglie-Bohm, David Bohm, and de Broglie. I don't know his name, the first name, and it's called the pilot wave theory. But I have to admit, even though this theory is apparently existing, I never heard of it. So it came to me in an independent way, and whether you believe it or not, that's your problem. I know it did. But the thing is, apparently this theory has been bouncing around for a couple of decades and never been taken very seriously, even though it's investigated in a smaller group, because the mainstream scientists never took it seriously and never took it to investigate it more deeply. So it's only few people who investigated this pilot wave theory. It's an interesting theory, I think, and some aspects of it have certainly kind of they cut wood, like they say in Holland, but then translated to Dutch. It's snijdt hout. That's Dutch. But I like to add a thing. I was philosophizing, whatever, you know what I mean, about this whole idea, this whole theory, and then again I was confronted with the zooming in the room where I was. It was the zooming of flies and insects, and I found that very annoying. And so I tried to catch the fly, and I did. Now you would say, well, what has got a fly to do with quantum mechanics? Well, remember this: if you release a single particle, if you have a macroscopic object, an MO, and you release from that, then in that molecular macroscopic object, particles are bound. And the wave functions are limited, are bound, and are confined in small boxes. We know them as atoms, but we treat them quantum mechanically. We treat them as boxes. What you do is, for example, with a laser, you are putting energy in it to release one particle, or an electron gun, or whatever kind of gun, proton gun, neutron gun, whatever kind of gun. You are releasing that particle into open space. So what happens that wave packet is released, and it can disperse its energy into space. It's free at last, so to say, just like a fly in the big room. And when you look at entropy, it's also logic that it expands, because it can release the energy into a wider, bigger room. So it's logical that it happens that a wave particle, a bound wave particle, a BWF, and when it's released into an open space, then it becomes an unbound, an UWF, unbound wave function, and that spreads out into space. And that's what we actually see. But when it hits a screen, then again it is confined back again into a smaller space. So the wave function, what we call collapsing, but actually it's more that the energy of the wave function is confined in a tinier space. And I tried to catch the flies. I caught some flies yesterday, but what you see is actually the same thing. The fly, when it's released, it takes it moves into space more. It has more options to be at other places. But if you confine it to a smaller, I took some glasses, when a fly sits on the window or on a flat surface, you can put a glass on top of it and then shift the paper underneath it, and then you get it confined in a smaller space. Well, the same actually happens, kind of, with a wave particle. It is a part of a macroscopic object at first. Then it's confined in a very small, tiny box, actually, as a wave function. Then it's released, and then it gets open space. It can go wherever it likes, and then again, if it hits the screen, it is confined again in a very tiny room. And that was very interesting. So I thought I wanted to share with you this. Of course, there are a lot of differences as well. I mean, why is it ending up on the screen in that spot and not in another spot, etc., etc. Well, I think that has to do with the makeup of the screen. I mean, the screen is also existing of wave functions that are confined, and due to tunneling, I cannot imagine, I cannot get rid of the idea that also the wave functions that are bound in the screen have some non-locality that interacts with the non-locality of the particle that is coming to the screen. And that may be guiding that particle, or maybe it shifts during its way, that it confronts with more than one wave, a non-local wave function of the bound particles in the screen, where it's guided to hit that screen, the screen on that spot. And what you see there is a quantized number. In the middle there's a big heap of particles ending up, and to the sides is lesser and lesser particles ending up. But I can imagine, and of course it's imagination, and you have to be very careful with imagination. You can imagine a whole lot of stuff, but imagination in science is very dangerous, because imagination may not be the reality. But nonetheless, I can imagine that a particle is guided through the non-local parts of a wave function in space with from the screen, and that is guided by those wave functions because of interaction. What I think is that the universe consists of at least four-dimensional height, width, and breadth. You know, the coordinate, normal coordinate system, including with time, at least four-dimensional vibration states over the entire universe, and that actually we live in the universe as a vibrant, and we know this. I mean, there is a Casimir effect, which we know that happened, is true. It's factual, it's measured, and it can be used or avoided in very tiny parts. So we know that the universe is a vibrating, at least four-dimensional space-time. Maybe there are more dimensions, we don't know, but space-time, it's vibrating. And personally, I think that vibrating space-time is creating some particles, just like vibrating waters is causing standing waves. And I think that the universe is one vibrating in itself, how do you say, interacting standing wave things, and the particles are the standing wave stuff that's causing particles. Next to that, that vibration, I explained it in an earlier movie. The vibration is also causing gravity. Why? Because there are quieter places in space and less quieter places. And the more vibrant it is, it's like the dust in your house. it's vibrating to places where you don't walk a lot. So it's moving towards parts that is relatively quiet in space, and that's what we also see in the time with a big mass. The time is slowing down in the neighborhood of a big mass. Apparently, it's less vibrant. In the open space, it's much more vibrant, and that pushes dusts and particles to lesser vibrant surroundings. That's one idea. Another idea, this is one approach. Another approach may be, what was it? I have to think about it some more. Particles, the wave functions of the non-local parts of wave functions are adding up and creating a gravity well. That's another possible approach of gravity. So you have a particle here with a wave function that's pretty vibrant, and that's the local part. That's the part that we see, that we perceive, and the non-local vibrations together with other particles are adding up to create a gravity well. So that's another possibility. And slowing down time, because apparently curved space consumes time. If you go higher speeds, then that consumes time. Gravitation, a lot of energy, concentration of a lot of energy consumes time. That's what we see in general. If you move faster, then that consumes time. Your time is slowing down relative to the other parts that are not moving of the universe. So energy put together, whether it's in mass, whether it's in motion, speed, it consumes time. So, what is energy? What are particles? It's a vibrating state. So, heavy vibration in a particle, and such a heavy vibration that it condenses to a particle, it's a standing wave. Apparently, a particle consumes time. Maybe it is because space itself is in such a way of vibrating that space-time is bent, and so time in the particle is used up and stretching the space-time around it, so that time is consumed in the non-local parts of the particle. That's an idea which I'm currently thinking, that curving of space-time consumes time, the use of time. Why? Because it's bent and it's vibrating, so it uses time. It's not a big amount. I mean, you need a whole Earth's mass, which is about 6 times 10 to the power of 24 kilograms. So it's a lot, and it only slows down time for 5 microseconds per year, something like that, on the level of 5,000 feet or something like that, 1,500 meters. But I think that highly vibrating space-time is consuming time. Maybe it stretches the space-time, and in stretching it's consuming time. At least that's my thought at this moment. But wherever you go, if there's a high concentration of energy, whether it's in space, in particles, or it is in movement, it always consumes time. Time is slowed down, maybe stretched out, wherever is a big amount of mass. That's what occurs to me recently. This is what I want to share for the moment. Maybe I come up with some other ideas. I don't have the math to put it in nice formulas, but this is I'm trying to convey some ideas of quantum mechanics, but also gravity. I think they are linked in some way, and that gravitation is actually a side effect of how matter is made of, how matter functions, and how matter, the wave functions, is using time, using space, etc., etc., etc. So that's what I at this moment think. And what you see is that the universe is one big vibrating, connected in itself. I mean, we are all connected due to entanglement to the rest of the universe. We cannot escape it apparently. And there is one. We are one with the universe, so to say, in that way. Why? Because we are consist of particles that are a vibrant state of something that is vibrating. I don't know what it is. That's my thought at this moment. And due to entanglement, due to tunneling, we are connected with the rest of the universe. In physical, this is purely physical. I'm not speaking about spiritual. Some people get carried away with this kind of stuff and they say, oh, you see, our spirits is hocus pocus is and hocus. Sorry, folks, this is pure physical where I'm talking about right now. Yeah, okay, get it? So I'm talking about matter and time and space, and I'm not talking about spiritual things. That's another subject that is interwoven with the materialistic things. But I think the spiritual realm, the spiritual kingdom is a totally different kind of, has a totally different kind of consistency than the material, everyday, touchable stuff that we are built of, at least our bodies. The spiritual thing is a whole other subject. They are linked with each other, yes, but when I'm talking about quantum mechanics and all the kinds of weird things that are from quantum mechanical things, personally I think it's got nothing to do with spiritual kind of things. Okay, but that's my opinion. Okay, this is what I want to share. Hope you understand it, hope you enjoyed it, and I don't know if I'm right. I hope I'm right, of course. Who doesn't? And this is what I want to share with you. Okay, thanks for watching. Hasta la vista. See you next time. Bye.